Lesson 12.1, functions involving square root. Now, if you remember what a function is, this is going back all the way to the beginning of the year when we learned what the word function meant. And what it meant was, for every input, there is one output, only one output. So that means, okay, I've got something that I can graph. That's the whole point of a function, is I'm able to see it on a graph. Because what I have is something like, if you remember what we were doing early in the year, y equals mx plus b. Remember that? We were able to graph because we knew what our b was, which is our y-intercept. Then we used our slope to find the next point. And on our graph, we would go 6 to 2. Actually, I think it would be the other way. Anyways, okay? And so we would draw our line, y equals mx plus b. Because this was a function, we could graph it. For whatever I plugged in for x, there would be one value and one value only for y. So what we're going to do today is we're doing this exact same thing, not necessarily with y equals mx plus b, but what you're going to do is your function is going to involve some sort of square root. Now, you should not worry at all because we have our calculators which can tell us exact square roots. And if there is no exact square root, we can always find a decimal, something close to the square root. Okay? So, but before we can even do that, it wants us to list the domain. Now, if you remember, domain and range of a function would be your domain is x and your range is y. So they want us to find the domain. What values can I plug in for y so that I can find my range, so I can actually set up a chart and graph it? Now, there's one thing about square roots, okay? Remember we talked about this a little while ago. We said, can there ever be a negative number under the square root? No, never. It's going to end up with imaginary numbers. Now, there is a certain way that you can do that and you can graph it, but we're not doing it in Algebra 1. You would do that in Algebra 2. Okay, so we only want to deal with real numbers is what they're called. Any number that's not a negative. 0 and up, okay? So, what I've got to say is, what can x not equal? Because there's going to be some things, because if I were to plug in, let's say I plugged in a negative 2 for x, would that be okay? Could I graph that? No, because what's the square root of negative 2? Undefined. We can't do it. It's not a real number. So I've got to figure out, okay, there's some domains that I cannot plug in for x because I will not get a value of y. It'll just be undefined. And then how can you graph something that's undefined? You can't do it. Okay? So what I want to do, and this is the easiest way I can tell you to do it, set up an equation because we know that x has to be equal to 0 or greater, right? Because it can never be, x doesn't always have to be equal to 0 or greater, but it can't produce a negative number under the square root. So what you want to do, the easiest way for me to tell you to find out the range is to set whatever is under the radical equal to 0 and solve for x. That will tell you the number or set of numbers that x cannot be smaller than to give you a negative number. I'm like, okay, I don't understand what you just talked about. Let me show you. What you want to do is take what's underneath the radical. So what's the only thing underneath the radical right now? X. So we're just going to put it equal to 0 and solve for x. Well, is there anything to do to solve for x? No. So I know that as long as x is 0 or bigger, I'm fine. So my domain, this is how you want to write it. You ready? X has to be greater than or equal to 0. There's your domain, just like that. Because I know if I plug in any number smaller than 0, I'm going to get an undefined. I can't do it. That's all they want you to do there. So let's do that same thing with x plus 5. Or y equals the square root of x plus 5. Let's figure out what can I not plug in. So we're just going to take what's underneath the radical and set it equal to 0. So I'm going to write x plus 5 is equal to 0. And let's solve for x. What would I do to solve for x? Subtract 5. and x is equal to -5. So I know if I plug any number in smaller than -5, what am I going to get? Let's say if I plugged in -6. What's -6 plus 5? -1. Could I have a negative number under the square root sign? No. So that's how that equation works. So I know my domain is going to be x has to be greater than or equal to -5. So wait a second, I thought we couldn't have a negative number. What is underneath the radical? It adds with something. So let's plug in -5 and see if I get a negative number. -5 plus 5 is 0. So did it give me a negative number? No, not in my final answer, so I'm fine. But if I plug in a -6, that's when you're going to get a negative number, and you can't have that. So I know my domain is all numbers greater than or equal to -5. All right, let's do that same thing. What would I do here, Christina, for the third problem? X minus 10 is equal to 0. Perfect. Kenny, what would I do now? Okay, Olivia, help him out. What would you do? Add 10. All we got to do is solve for x. And x is equal to 10. But is x equal to 10 my final answer? No, because I want to find the domain. So, x has to be what? Greater than or equal to 10. You say, hold on. Why does it have to be 10? I thought it would be like 0 or any number smaller than 0. Let's plug in a 9 and let's see. Because 9 is smaller than 10, right? So, 9 minus 10 is equal to what? -1. Can I have a negative number under the radical? Nope. That's a really easy way to check it. Do one number smaller than the number that you're saying x has to be greater than, and one number larger. So let's try 11. 11 minus 10 is what? 1. So am I okay there? Yep. I've got my domain and I can plug in and find out, okay, as long as my domain stays 10 or greater, I'm fine to graph it. Okay? That's what we're working up to here, is we're working up to what numbers can I plug in into an X and Y chart so I can actually graph it? Because what if you had that equation right there and you started at -1 or -2, -1, 0, 1, 2? Would you be able to do any of that on a graph? No, because they're all smaller than 10. So you're saving yourself some time here by finding out what does X have to be greater than or equal to. All right, what about this next one? How would I solve it? 2x is equal to 0. What would I do? Divide by 2. And what does x equal? 0. So, what does x have to be greater than? 0. X has to be greater than or equal to 0. And last but not least, this one can be tricky. Because we've got, we got one more. Sorry, I almost skipped it. 6x minus 18 is equal to 0. What would I do first? Add 18. Then I have 6x. So we added 18, then we get 6x is equal to 18. Then I divide by 6. And what does x equal? 3. So I know that x has to be what? Greater than or equal to 3. And last but not least, this one is the one that can be a little bit tricky. Because we've got 5 minus x is equal to 0. What would I do first to solve for x? Subtract 5. Why wouldn't I add 5? Because 5's not negative. The x is negative, but 5 is not. So I subtract 5, and I get negative x is equal to negative 5. Can I just say, oh, x is greater than or equal to negative 5? No, what do I need to do now? Divide by negative 1. And what does x have to be greater than or equal to? 5. Very good. Okay? Now, let's put that into practice. How would I use that to graph an equation, or a function, I guess I should say. So example 2. Alright, so when I want to graph this, before I go to graph, I need to figure out what numbers can x not be equal to, because I want to save myself some time, because if I just sit there plugging in numbers, okay, and I'm getting undefined for y, I'm just wasting my time because I can't graph those. So what I want to do is I want to say, what do I need to set equal to 0? And the answer is whatever is under the square root sign. Most people right here go, okay, x minus 2 is equal to 0. But is minus 2 or negative 2 underneath the square root? No, it's not. So it does not need to be set equal to 0. So the only thing that needs to be set equal to 0 is x. So I know that as long as x is greater than or equal to 0, I can make my x and y chart and I can graph this. So let's do that. Let's make an x and y chart. Since I know it has to be greater than or it can be equal to 0, let's start with 0. And let's just do 4 numbers. Whatever your domain is, whatever number you have x is greater than or equal to, blank, whatever it is, always start with that number and go 4 numbers higher. So we're going to start at 0 and we're going to go 1, 2, 3. There's 4 numbers. We're going to plug each of those numbers in. This is where you're probably going to want a calculator. And we are going to solve for y so that I can graph it. Now, you are going to be getting some decimal numbers here. Because does 2 have an exact square root when I go to plug that in? No. So, when I do that, I'm going to get a decimal. It is okay to get a decimal. Do not panic and say, oh, there's no exact square root, I can't do it. So this is what we're going to do. We're just going to take this equation, y is equal to the square root of, what's my first number I'm going to plug in for x? 0 minus 2. What's the square root of 0? 0. What is 0 minus 2? Negative 2. Just the 0. Now, you say, I thought we can't end up with a negative number. No, a negative number for y is totally fine. It's what you don't want to end up with is a negative number underneath the radical. Well, since we found out that y can't be anything smaller than 0, I don't even have to worry about that. We will never have a negative number under there because we took care of that in the very beginning. So let's try 1 now. Y is equal to the square root of 1 minus 2. What would I do first to solve this equation? What's the square root of 1? 1. 1 minus 2 is negative 1. Do the same thing. Y is equal to the square root of 2 minus 2. Now, am I putting that minus 2 under the square root sign? No, because it wasn't in the square root sign in the original problem. So I only put what x is going to be equal to underneath the square root sign. And what's the square root of 2? 1.4. Is that rounded? Okay. Okay. So let's actually round to the nearest hundredth. I always want you to do 2 decimal places. So if it's 1.41, correct? What's the number after 1? 4. So this is going to stay 1.41, right? Now let's subtract 2 from that, and what would I get? Negative 0. What? 59. Now, if I want to round to the nearest hundredth, which is 2 decimal places, what would that round to? What would that round to? 0.06. And what type of number is it, positive or negative? Negative. Alright, I just boxed it in so you could see it. So then, when it's equal to negative 2, we've got 0.06 negative. And last but not least, the square root of 3. Square root of 3 minus 2. What's the square root of 3? 1.73 minus 2 is what?
Negative 2.7. Negative 1.7.
Okay, so it's negative 0.27, correct? Yes. All right, so now we're going to go negative 0.27. Hold on 1 second. When you plugged in the square root of 2, which is 1.41, and you subtracted 2, are you sure you got 0.06? It's 0.59. Okay, that makes more sense. So this is supposed to be negative 0.6, right? There's a 0 in front, but no 0 right there. So when I round, that makes more sense. Negative 0.6. 0.27. That is the rounded to the nearest 10. So you would round it 2 decimal places. But because this one is a 9, that turns that to a 6. And what's the next number then? 0. So I don't really, so it would technically be 0.60, but you don't really need to write that 0 behind it. Okay, so let's graph this now. And if you want to, I've got actually a very large graph because I can determine what type of graph I use since I'm doing it on the computer. But whenever you do it, if you want to graph and use like each line is a half, so it would be 0, then a half, then 1, then 1.5, then 2. Because when you're graphing decimals, if you do each line is equal to 1, your dots are going to get really close together. And it might be easier to skip a line in between your numbers. Now, I'm not going to do that because I have actually pretty big spacing on my graph. But if you wanted to do it like this, that would probably make sense for you guys. Alright, now that I've got my graph all labeled, I'm going to plot my first point, which is 0, negative 2. So 0 on the y-axis, I just stay right here at my origin. And then I'm going to go to y, negative 2, so I'm going to go down 2. There's my first point. Then I have 1, negative 1, over 1, down 1. Then I've got 2, negative 0.6. Now, negative 0.6 is going to be a little bit lower than negative half, right? Because it's a little bit smaller than that. So I put it as close as I think it's going to be. Obviously, you're not going to get the exact 0.6 or negative 0.6, okay? You're just going to try to get close. And last but not least, 3 and negative 2.7. So it's probably going to be somewhere right around here. And we always want to draw a line through our graph. And you don't want to, actually, I'm sorry. You do want to start right here. Because remember, every number smaller than that first point is going to be undefined. So the line will not go farther than your smallest point, or whatever you started your graph with. But it is going to continue because it's all numbers greater than 0. So if we wanted to plug in a 4 or a 5 or a 6, it would keep going. But it's not going to keep going beyond the 0. Now, if you look at this line, what type of line is this? Is this a curved or a straight line? Curved. Anytime you graph these, it will always be a curved line. If you got a straight line, probably did something wrong. Okay? That's how we use what the domain of x is to graph an equation or a function with a square root. All right, so let's do another one of those. Let's look at this problem now. Example 3. Before we want to graph, before I want to get my x and y chart, what do I want to find out first? Keone? The domain of x. So I've got to figure out what numbers can I even plug in for x so that I can begin to graph it. And how would I find that out? What would I do to find out what the domain of x is? what has to equal 0? What is underneath the radical. So let's look at this right here. What's underneath the radical? X minus 3. So I'm going to write x minus 3 is equal to 0 and solve for x so that I can find out, okay, what numbers can I plug in for x? What would I do first? Add 3. Perfect. So I know if x is equal to 3, that means my domain has to be x is greater than or equal to 3. So let's make our x and y chart. What am I going to start with? 3. And how many numbers am I going to do? 4. So I'm going to do 3, 4, 5, and 6. Plug them in and solve. So we do y is equal to the square root of 3 minus 3. What's 3 minus 3? 0. What's the square root of 0? 0. First point. And then we do the square root of 4 minus 3. What's 4 minus 3? What's the square root of 1? 1. Then we do 5 minus 3. The square root of 5 minus 3 is 2. What's the square root of 2? 1.41. Remember we did that last time? 1.41. And then we do, last but not least, y equals the square root of 6 minus 3, which is the square root of 3, which is 1.73. Now let's graph it. Alright, so our first point is 3, 0. So I go, well, let me label my graph first. Alright, so my first point is 3, 0. So I go over to 3. Then up or down 0, so that means I'm not moving at all, so I just put my point at right here on the x-axis. Then I've got 4, 1, so I go over to 4, up to 1. Then 5, 1.41, so I'm going to go up over 5, up 1, and then a little under halfway. And then 6, 1.73, that's going to be a little over 1.5. Now, is my line going to extend through 3, 0? Like keep going like this? No, because remember, 3, 0 right here is your first point. We cannot have any point smaller than that because x can't be equal to it. That's where my domain stops. So I start my line here and it extends through. Now, will I have numbers that are bigger than 6 and 1.73? Yeah, because I can plug in a number and I won't get a negative x or a negative square root. Okay? So that's how you would graph functions with square roots. Okay? You got to make sure you find the domain of x and solve from there. Okay? Lesson 12.1.